Good afternoon, everybody. Thank you so much for coming back. I hope you had a chance to visit the booths and maybe make use of one of the tables. I'd like to introduce our second speaker for the day, Will Cadell. Will and I have had some fascinating conversations over the years. A little bit of background on Will. He founded Sparkgeo, global modern geospatial consultancy. Will is a business leader with a background in engineering, remote sensing, and strategy. He loves discovering and building new markets for scalable geographic technology. He's also advising an investment community on geo-focused businesses and chair of the Innovation Central Society, a nonprofit focused on supporting technology entrepreneurs in northern British Columbia. Will was also involved in getting GeoIgnite up and running. And GeoIgnite, as you may know, is partnered up with the Light Conference, and we're expecting to do more stuff together, which should be very interesting. Without too much further ado, let me pass it over to Will. Take it away.
Thanks very much, Arthur. Much appreciated. I would say for GeoIgnite, that was very much John's effort. All I said was, it sounds like a good idea, and from then on, it was all his. So I'm gonna have a crack at sharing a screen. If someone can give me a gentle thumbs up, if it works, I would be very much appreciated. I'm thinking we're good. Oh, we got lots of thumbs up. This is amazing. Thank you very much indeed. Very much appreciated. So my name is Will Cadell. I run a company called Sparkgeo, and I want to talk about pipelines in the sky, workflows for modern geospatial companies, technologies, processes, generally workflows for modern geospatial. Oh, there we are. This is one of my favorite quotes. Like, there's not a great deal that's amazing about the book Neuromancer, except for this quote, because this is absolutely true. For so many of us, the future already exists. We're living it. But it's not evenly distributed amongst different organizations. So this speaks to the history of Sparkgeo, because I was born, or I created Sparkgeo to put maps on the internet in 2010. I came out of the resource sector. I'm kind of a Scotsman lost in northern British Columbia. So I came out of the resource sector. And I thought, hey, we should put maps on the internet. It seems like a really good way of doing maps. That's kind of at the beginning of when you could do things with Google Maps, right? Sort of back at the beginning, we had this notion of slippy maps, all that kind of stuff. And since then, we've been engaging with the technology sector, and the technology sector typically does things, not a big surprise. Technology people do technology things first, yeah. But you get used to certain workflows that become normal. So the use of the cloud would be a normal thing. In fact, I would a number of times I would be wandering around having lunch in San Francisco with the clients, and I'd say to them, you have to realize that there are geospatial technologies out there. There's packages you can buy, and there's this you can do, and they would say to me, that's great, Will, but we really want to own our IP, so we need to have this thing, whatever it is, deployed in using open technology, and we're going to put it on the cloud. And I'm like, that's great. So what you'd end up doing is building a whole bunch of stuff based on a foundation of open source and open standards, and then you take that and you put it on the cloud. Interestingly enough, often a proprietary cloud. So there's that kind of weird sort of dichotomy between open source stuff and proprietary stuff, and the dividing line was this notion of infrastructure, this notion of deploying IPable software into an infrastructure that could take that software and scale it up. So those organizations were very into cloud technology a long time ago. It was overtly the way to go because it reduced sort of upfront capital costs. However, I would argue that not everyone in geospatial has had the same distribution of the future that the technology sector has. And we're still talking about the use of cloud technology within geospatial and what that means to us as a community. So I wanted to take a little bit of time today to talk through geospatial and with a particular kind of cloud lens, or maybe we're going to talk about the cloud through a geospatial lens. It's probably a better way of putting it. So let's dig into this. Goodbye, Mr. Gibson. Quickly, Sparkgeo is a geospatial consultancy. We provide analysis, data acquisition, usually novel data acquisition, so things that you wouldn't necessarily easily find elsewhere. Geospatial advice and consulting, so we'll provide some kind of market intelligence advice, but we'll also say, hey, this is how you can sculpt your geospatial product appropriately. This is the way the markets are moving. And we'll provide overt sort of cloud-centric geospatial application development. So I like to say that we have opinions and we can back up those opinions with code. We've been lucky enough to work with some really interesting and weird and wonderful clients, which have given us lots of exposure to how different markets do different things, how different verticals approach different problems, and how we as a geospatial community should be thinking about some of those problems. So we feel very blessed to work with some really cool organizations. So this is one of the key things that we do, is we join data sets together in the cloud. And the cloud allows applications to scale for data and traffic, more of that later, monitor at the speed of input sensors, more on that later, and be accessible anywhere, more on that later too. So Sparkgeo has only ever built cloud-centric technology. We've actually never owned a server. And we are kind of a remote by nature organization. I'm in the middle of nowhere in British Columbia. I've got a small team who are also in the middle of nowhere in British Columbia, but we've also got other people in other parts of British Columbia and Alberta, and even as far afield as Toronto, Arthur, to go back to where you guys are based. And we just recently opened an entity. I say an entity because we don't have offices, we don't have any real estate, but an entity, a business, if you like, in the UK, because we think spatial finance is going to be really important, and we want to be part of that discussion. So often I think of Sparkgeo as a glue company. We solve customer problems by assembling different solutions and gluing them together with either custom code or cloud technology. So we're not necessarily going to sell you a piece of software. We're not going to sell you a license for something. We're going to listen hard to the problems that need to be solved, and then we're going to try and create solutions based on the best of breed technologies that we see in the marketplace for a particular purpose. And often we have to create glue to join legacy data with new technology, or cloud things with sort of enterprise processes, a whole bunch of different things. Glue is really what we and that, so the glue and the product focus for that glue is really what we sort of drive into our business. And I should say, if anyone's got any questions as we roll through this presentation, don't hesitate to throw them into the QA, and I will try and address them on the fly. So don't hold back. So what do I mean by pipelines in the sky? I like to describe Sparkgeo as the least contentious pipeline company in British Columbia. Like we're broad of the British Columbia now, but it was a kind of a useful way for me to sort of help people understand the nomenclature around how we should be thinking about this notion of modern geospatial. I went on a trade mission to the UK, like back when we were allowed to get on airplanes and stuff. Trade mission to the UK before COVID, and it was a wonderful opportunity. And on that trade mission, I picked up this nomenclature, very kind of oil and gassy nomenclature for geospatial, which makes actually a surprising amount of sense. You have this upstream component where you collect data. It could be satellites, it could be cell phones, any number of different stuff. And you have a downstream component where the data is used. And in the middle, you got to move the data around, and you got to refine it, and you've got to, maybe you distill it, you do stuff to it on its way from pixel or point to product. So that's actually a really interesting and useful way of thinking about it. So when people say, oh, what do you guys do? I like, oh, okay, well, often we build data pipelines. So we build these pipelines, we fill them full of data, and we throw them up into the sky, and no one really complains too much. And I find that a really useful way of describing our typical workflows. So I think about that, and I think about why now. And this is actually a really important point. So we've seen the rise of 5 complementary assets in the last decade, I'd say. So we got smart devices, we've got commercial space, we've got cloud computing, we've got open standards, and we've got algorithms. So all these sort of really complicated, like national Earth observation programs, which needed kind of infinite compute, massive data collection projects, they could only be really touched by governments before. Well, now they can be undertaken relatively inexpensively by the technology sector. I like big shout out to Wyvern Space out of Edmonton, who are a very small team building, who have aspirations to build hyperspectral constellation of satellites. That's really amazing. It's a very small team. They've just done a raise. I think they got $4 million raised in their most recent raise, which I think is it's either a seed or a Series A, early stage. But you could never have achieved that 10 years ago, not even close. So that's really interesting. And as a geospatial guy, I think, oh, now I've got this whole new suite of data products that's going to be available to me. What can I do with that? How can I describe that to my clients? What pipelines do I need to build? So those organizations that are interested in understanding landscape changes and also human activity can now do so at a national or planetary scale. But what's really interesting is there are as yet no sort of overt dominant designs for how the financial sector or other sectors, frankly, might consume geographic data. What do I mean by dominant design? A car typically has 4 wheels. It has the engine out the front, it has a windshield, and it has some kind of storage at the back. Like, who designed that? Why is it that way? It has become a dominant design. A hamburger comes in a box or it comes in a bag. It has 2 pieces of bread and a piece of meat inside. Who designed that? Why does it look like that? These are dominant designs. These are kind of accepted by communities as the way a particular product looks. So if we think about geospatial, the classic dominant design was, oh, here's a map. That's great. If the community you're selling to can consume a map. I often think of a map as being a bit of a barrier these days. I love maps. Maps are my life. I'm an outdoors person. I just love looking at maps. I get immersed in them. But I now come to realize that potentially a map and potentially an image is a snapshot of something. And maybe we need to think about other ways of communicating geographic change. It's important just to have in the back of your mind. So I would argue that this notion of modern geospatial, and call it what you will, that's what I've called it, is an entirely new market. It didn't exist 10 years ago. And I think that's an important thing to consider. So scale matters. We've got 7 billion GPS-enabled smart devices on our planet right now, capturing location of either, I don't know, check-ins of this, or like tracking locations of my Strava run, or whatever it is. Like, these are GPS-enabled devices. They can tell us stories of geography. More often than not, not actually more often than not, I would say that there is an increasingly prevalent trend of having LiDAR built into these devices too, which means that not only are we capturing points of interest, we're capturing 3D models of our surroundings. For For what purpose? I don't know, but we're going to let the community figure that out. That's an amazing opportunity for us. I would argue that maybe the typical planimetric map might also change to a first-person experience. We have hundreds of terabytes of data flowing out the sky every single day. Hundreds. I used to say that there were tens, and I've come to the conclusion that there are hundreds. There's probably, if we were to count everything, there's probably petabytes of data flowing out of the sky every single day, and then more tomorrow, and more the next day. And then on the other side of this coin, I would say in British Columbia alone, we've had heat domes, polar vortexes, atmospheric rivers, wildfires, landslides, catastrophic flooding, all within the last 9 months. So these are scales that we need to be considering. Super interesting subject. Another scale, a tip of the captain's wheel completely blocked the Suez Canal for over a week. $10 billion worth of goods stalled every day. You know, that's a wildly scalable event. And if we start thinking about that, we start thinking about very geographic items. We start thinking about supply chains, and we start thinking about global risk. And we start thinking about globalization. And all of these are geographic in a meaningful way. So this is what I start meaning about scale. We're thinking about time. Now, often in geography, we were considering space, but time is actually every bit as important to geography as space is. We're now thinking about the speed of impact. We're thinking about the impact of the speed of change. How often and how quickly do landscapes change? How often and quickly do people change? We're thinking about the speed of science. How do we describe how science is evolving our thinking around climate, is evolving our thinking around epidemiology, is evolving our thinking around technology? We're thinking about the speed of politics. You know, how quickly does your Black Lives Matter road appear in your map? How quickly do borders change? Very relevant today. And then we're thinking about the speed of people. Where are people moving? How quickly do they move? And how should we be thinking about that? And when I think about geography now, I'm thinking about where landscapes change and where humans move. There's overvalue for our community to be measuring, and we need to be thinking about that measurement. And that is why we need scale. At one point, we were thinking in terms of snapshots, and now we're thinking in terms of time. And I think time is absolutely pivotal to the discussion of modern geospatial. So to do that, to get to scale, we need to be thinking about cloud workflows. And the neat thing and the nature of a cloud workflow is it can start off tiny and it can get really big, but only if you want it to. And that's the power. So if you think about that in terms of a national mapping program, well, you know it's going to be big. It's a national mapping program. It's got national scale, and conceivably beyond national scale. But if you're a technology company, it doesn't have to start off big. You can experiment, you can decide, you can iterate. So the cloud supports iterative innovation. And with that iterative innovation comes this notion of discovery, and comes this notion of invention. And I think that's one of the most powerful ideas to bring away from this. When we talk about scale, we talk about cloud, we talk about data storage. You know, the big winner with commercial space and what we're calling new space is really the cloud providers and data storage capacity. Mr. Bezos will do exceptionally well off new space. I think we can all agree on that. But when we have that massive amount of data in these data catalogs, for instance, at Sparkgeo, we're a big fan of the spatiotemporal asset catalog stack. You do need to be able to join them together. So you need some notion of open standards to do so. And then we have to have some notion of why we're using a cloud and what we can use the cloud for. So we think about determining a process and then doing it many times. And the neat thing about a cloud or a cloud-based process is that you can create patterns and then you can deploy them elsewhere. Create a pattern, deploy it, create a pattern, deploy it. And they can be containerized and then they can be deeply repeated. So in practical terms, what does that mean? That means we get to, instead of creating a snapshot of our world, we get to create a measurement, and then we get to continually monitor that measurement. And it's so important to think about that process, because that's the difference. That's what we can do now that we could not do meaningfully in the private sector 10 years ago. So when we think about patterns, we think about things like this. I'm going to brush over the slide. It gets a little bit techy, but we're thinking about discrete processes that we can repeat and sort of pipe in different data, pipe in different algorithms, pipe in different user interfaces conceivably, but ultimately it's the same pattern and it is deeply repeatable. And that's what's so exciting about what we see here in terms of the cloud. So this is a paragraph directly from a blog post that it's either been published today or it'll be published in the next week or so. But our team has been looking at linkages around wildfires and around landslides. I'm going to dig into that a little bit more deeply in a second here. But we are likely to see wildfires increase by more than 50% by the turn of the century. Like for me, turn of the century is a ways off, but in terms of our community, that's really important. So to mitigate that exposure, we need to understand how their impact and how they interact with ongoing natural events and hazards. So let's think this through. So when I talked earlier on about repeatable components, we have a toolkit that we've called Prescient, which in essence is this notion of kind of looking ahead, but not necessarily knowing quite what's going to happen, but we have a sense of what's going to happen. And that's what our technology is helping us do. And that's what these repeatable patterns, which really is what our Prescient technology is. It's a series of repeatable cloud patterns. It's helping us understand causes and chains of events. So atmospheric river that struck Abbotsford near Vancouver, and we were looking at the extent of the flooding, and you can see that in this GIF that's presented in the back here. What's important to realize that hiding behind the pixels of this image are hundreds of families that had no idea they were at any kind of a risk, as well as the supply chains and the agricultural communities that also did not have any sense of their climate-related risk. So this is important because that summer we had a series of pretty devastating wildfires. We get wildfires relatively frequently in British Columbia. We get a lot of exciting things in British Columbia, it turns out. So we had wildfires, and then subsequently we had landslides. And what we wanted to decide, because a lot of our homes are in British Columbia, we wanted to figure out if there was some sense of linkage, because it felt like maybe there should be, or at least there was something happening there. So what we were doing here is, we're thinking about that measure element of the measure and monitor ratio. And we started thinking about that. We started looking at various different areas. So this is the Coquihalla. If anyone's familiar with this, it's a major northern It's a major highway that links Lower Mainland to the rest of British Columbia. And that orange outline is the outline of a fire. So you can see here, that's it before the fire, that's it after the fire. So we've kind of captured the fire pretty loosely there, but you can see it. I mean, it's quite striking, definitely there. And if we move on, we've run through a process of identifying the fire area automatically using sort of a cloud, using like typical Earth observation techniques, before and after Earth observation techniques. And then we started thinking, oh, that's really interesting. So let's link that to where those landslides were. And that's what we're showing here. What you can see is there were various landslides along the Coquihalla that came in after the atmospheric river that line up exactly with where the major fires were, and we did not detect that many landslides outside the fire zone. So we're not saying landslides, fires cause landslides. No, not at all. What we are saying, and you can see an illustration of it here within one watershed, is where you have a location that has been burned, there is less to absorb the water. And what that means is the water's got to go somewhere. The water flows. So when you have topography, water flows down. And you can see in this graph here, this is looking at fall precipitation through a number of years, and you can see it's fairly steady. And then in 2018, when you have this large fire event, and this is in a different watershed, but you have this large fire event, when you can see that the total fall discharge in the river spikes. So the orange line measures like pulses of water, how much water is coming through a location. But the blue line is telling you how much precipitation fell. So the precipitation didn't rise dramatically. No, but the water hit the river very strongly. So what we're saying is this big pulse of water could be, we're still doing the research, could be, and seems logical that it would be linked to the fires that happened earlier. So conceivably, increased fires in a particular basin increases your risk of flooding at a different location, further down the river. So this is the notional increase in climate risk exposure. And I think that's the important thing to figure out, this notion of climate risk exposure, because we had this enormous atmospheric river event, and that's what really set off these landslides. The landslides didn't happen because there were fires. The landslides happened because of a subsequent event, the atmospheric river. So now we're starting to see that there are chains of events. It's not a simple, easy linkage. And now if we sort of dig into it a little bit further, we can see that in the Coquihalla in particular, you can see where those flood events were. We got a little bit of a tilt going here, and you can start seeing how the landslides are somewhat related to the location of those fire events. And we got pictures of the landslides coming in here, so you can see how that rolls. So here are the two things I want you to be thinking deeply about when we're thinking about scale. And the example I just provided. One, time. Measuring and monitoring changing risk. Managing for new fires and basins and broadly in catchment. So one fire in itself isn't going to cause necessarily a terrible flooding event lower down the river, but an accumulation over time might. Fire causes this kind of hydrophilic notion. It means water flows over it. So a hydrophobic notion. Water flows over it. In the same way that in the Gulf region of the United States, if you cover a wetland with concrete, water needs to flow somewhere in the event of a large storm, of which there are frequent storms. There are seasonal storms. So if water has to go somewhere, it might end up in your in your basement. If someone, elsewhere in the catchment has decided to build a new parking lot. So these are important things to consider as our surrounding landscapes change, how we can start thinking about joining some of these concepts together and understanding how we can mitigate or at least understand there are changing risks to climate events. So one, time is incredibly important. And so snapshots merging into monitoring opportunities, and then scale is incredibly important. So as an individual, as a consumer, how do I engage with these climatic events? Like, can I do anything about this? Can I be helped in some way? Maybe we need a walk score for climate risk. Can I check to see whether fires in a region 100 kilometers from my house have now put me at a greater risk of flood? That would be an incredibly useful service, and a service that we will see emerge over time. Let's think about mortgages as a whole. Are we able to understand risks to mortgage portfolios based on changing climate circumstances? These are really interesting and slightly troubling questions that I don't think as a community we're ready for, but we do have the technology now, which is great news. So climate risk doesn't just happen in British Columbia, manifest across our planet. So our changing landscapes and growing populations are at odds. We've been looking at some work in Saudi Arabia. They have a reverse problem to us in that extreme heat causes scarcity of water. So this notion of either having too much water or too little water, the notion of water in general terms as a climate risk vector is important for us to understand. So that's really the message I wanted to leave you with, that there are these repeatable cloud patterns that we can employ to start understanding planetary related concerns at scale. And I think that's where the geospatial community needs to focus, and that's really where we can add most value to the community, the rest of the community as a whole. So climate risk for real people. Hopefully we can start riffing on that idea a little bit more. Thank you very much. And I'd love to hear some questions.
Hey, well, thanks very much for that. That was very entertaining. Nicely woven in with Abbotsford there. So we do have some questions, Will. So stand ready. The first one is actually I'm invoking chair privilege and asking the first one. So the concept of landslides being associated with being exacerbated by the presence of wildfires. How deep have you gone there? So for example, have you looked at the physics of landslides? Have you looked at soil permeability changes? Is there a geology play, topology?
Topology, absolutely, of course. It's hard to have a landslide without some sense of slope. So that's really important. But the real point to sort of get stuck in our minds is this notion of, so it's not that one thing's causing the other. It's that it's this notion of increased flow and increased pulses. So it's the same amount of water falling out the sky. Oh, we have atmospheric rivers, but I have a suspicion that we had atmospheric rivers before we just called them heavy rain. But what we want to tell the story of is, because of these landscape changes, we have this notion of a changing flow, an increased pulse. So if you have this increased pulse of water, that's the danger. That's a piece we haven't readily accounted for before. We didn't really know about it before. And if we can see these pulses happening more broadly within an entire basin, or we can see the landscape change happening in an entire basin, then incrementally these pulses might grow and into something a little bit more concerning. So that's the piece that we wanted to understand. So it's not necessarily that, hey, fire here, therefore you're going to get these other problems. It's that this landscape change is concerning, and over time we need to be understanding how our risk to climate is changed, and we need to sort of just manage for that effectively.
Good answer. So just to continue the conversation a little bit, though, are you expecting that you will make recommendations based on the location intelligence studies? Like, okay, there should be a berm here, or there should be changes to the vegetation. We'll plant more trees, or
we don't have engineering resources for that. I think what we're more likely to do is help individuals understand their climate risk. It's interesting, that notion of a walk score. If you're familiar with walk score, it's like, how walkable is your neighborhood? And I think, oh, that's cool. That's a really useful geographic context for me if I'm going to buy a house. Well, why do I not get like a climate score, climate risk exposure? So I'm not saying that you're going to flood here for sure, but did you know you're in a 200-year floodplain? Did you even know that? I mean, that's useful information to know. Has it been raised to you by a real estate? So if you've got two houses, both of similar value, maybe you want to get the one that's just a little bit higher up or something. But just knowing that information from a consumer level is really valuable. And then if you think about that and you extrapolate it up, you think, okay, so for RBC, conceivably, how concerned would you be about the entire mortgage portfolio? I mean, that's a really interesting question too. So, but it's also that question of scale. So you got one person worrying about their one house, and then you've got a bank or some kind of financial institution worrying about thousands and thousands, hundreds of thousands, millions of houses. And what's the balance point there? These are really interesting questions that haven't, I don't think, been adequately tackled by our community yet. But now, I think the real point I want to make is we can do this stuff now. It's actually within our purview, but what we haven't done is necessarily describe to the broader community that these kinds of tools are available.
I think it'd be a really nice stretch goal from there to say that we can estimate the impact on the property value from the climate.
That is well beyond my pay grade, Arthur. But it would be nice. It would be nice to at least tell people, hey, you're good, or to have people on a scale of 0 to 5 that you're a 3 or a 4, so you're probably okay. That kind of thing. I then to know if there's change, and I think that notion of change here is really important because we're surrounded by that change these days. I'm up in northern British Columbia. Every summer now, our skies are covered in smoke. When I first moved here 15, almost 20 years ago, that didn't seem to be a thing, and now it's seasonal, and I think that's really strange. So what's happening? Or maybe it's nothing. Maybe I'm just picking up on a pattern. Nonetheless, it can have a direct effect on people's lives and livelihoods. So I think if we have an ability to do something about it, then maybe we should.
Very good. Very good. I have a question from Jeffrey, who is one of RBC's location intelligence specialists. And his question is, how good advantage current geospatial computing can take from cloud? For example, can one operation computing be distributed?
Well, obviously, there's caveats to that. I'm going to say yes, because you can usually distribute almost anything, but you'd want to sculpt that process in the most effective manner to get the best out of the cloud. So is it a parallelizable process? Typically, if it's Earth observation related, then it's pixel based, and it almost certainly it is. So there's that piece. If it's a distributable process, i.e., it can be done independently from other processes, then absolutely, even more so, you could distribute it across a network of computers. So yeah, I think in the most part, I would say yes. And we've built many cloud-based workflows that allow you to do something once and then to do it a bazillion times. Well, within the realms of fiscal reality, I would say. But obviously, you don't want to go too crazy, otherwise you get sent an exceptional bill. And I think that's maybe one of the concerns with adopting cloud is how big is that bill going to get? And and that's definitely a discussion. There needs to be some management around that.
So I'm going to invoke chair privilege. I got one more here that is one of my more favorite things, is that we execute location intelligence projects in all kinds of organizations in all parts of the country. Do you think it would be a reasonable thing to do to request that each of those projects actually has, even if it's just a small part of it, has a climate change lens to it? So you're delivering results, but you include in that some computation or some deliverable or some aspect that contributes to an understanding of climate change.
I don't think it's unreasonable at all. I mean, there's obviously context to that kind of stuff, but I think we need to understand impact on impact that we have as individuals on our society and on our planet. And I think those two things are really important. So thinking about ESG as a core deliverable, I think at least allows you to think about the context of your activities as a business, as an individual. So what is it that what am I doing? What have I been asked to do? This project, great. But what are the broader effects of this project? And how do they have maybe geographic effects? How do they have social effects? How should we think about the governance of this kind of data? I think it's important because often as technologists, technology can move ahead of policy, which can mean it can move ahead occasionally of ethics, which means that people do things just because they can, not necessarily because they should. And using that ESG lens slows things down enough for technologists to start thinking about whether they should. And I think that's important too. Or this notion of should within the context of sort of societal concern. So we were talking in environics before. We're talking about anonymization of data and location-based data. And I think that's a really good discussion to have, because that's exactly why we should be thinking about the ESG, the governance piece. If we're thinking about location data, then we should be thinking about the governance of that location data, what effect it has on an individual. Oh, but how can we mitigate for that? Maybe we anonymize data on source. So we don't know, maybe we have a minimum number of individuals who will, who need to make up a crowd before it becomes a crowd that is measured in some manner. So I think thinking about ESG in the delivery of almost any project across a nation, across the planet, I think is a really good lens to ensure that your deliverable is actually sort of respectful of the communities you're working with. Does that make sense?
Yeah, it does. It does. And sort of, we're running out of time here. I've just got a minute left, but I was just, Jan provoked me to think a little bit about what if there was a mobile app, and I can't fill in the blanks too easily, but what if there was a mobile app that everybody could play with that gave them an immediate readout on climate impact? What was your day like? What's tomorrow going to be like now that you've learned something from today?
Yeah, I think that's perfectly reasonable. I mean, I saw someone positing on Twitter that if you had a shorter work week, then we would have a very positive effect on the environment. And I'm like, I think that through. I think, yeah, that's probably right. Reducing the commute time by 20% would have an enormous positive effect. That's really interesting. So thinking those kinds of things through, and that, or saying, you know what, working from home is a really good thing for the environment. We should think about that. So I think we can, as individuals, just be prompted, gently reminded, gently prompted. And for me, I haven't really gotten any aircrafts recently. So my impact has reduced enormously. I used to be like airport lounge guy, and now I'm home office guy, which is fine. And I really like home. Like the sun's coming out. It's great. But at some point I'll go back to flying a bit, but I probably won't go back to flying quite the same way. And I think that's really interesting. It's like, okay, so my behaviors have changed a bit. And if everyone's behavior is changing a little bit, then we have a positive effect. Will that stop the wildfires in British Columbia? Not immediately. So we're going to have to still manage for those kinds of events at the same time as ideally managing our own behaviors a bit.
Brilliant. Well, let's wrap that up and on that high note. Thanks so much for your time, Will, and for presenting here. From the audience reaction there, it's pretty obvious people caught on hold of this and understand. They got the story all wrapped up.
Thanks very much, Arthur. Much appreciated.
Yeah, thank you, Will. Just so folks know, we've got a networking break now that takes us through until 3:15. Please go visit the booths. Find yourself a table if you want to chat with somebody. You can advertise on the table that it's something you wanted to talk about. You could find some very interesting people to talk to. We've got quite an interesting audience here. So please come back 3:15, where Dave Lamb's going to be talking to us about. He's a food agility specialist, and he's going to be talking to us. So please come back then and enjoy your networking.